Yeah, right. Let's take a look. Again, these are pretty similar, and so I don't think we need to spend a ton of time on that. I'll try to whip through it, but 30, and I'll use 29. It says in economic theory, a hurdle rate, la da 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 da. It does say that a normal distribution, or a mean, I'm sorry, of 12% and a standard deviation of 18%. Now, I'm going to tell you that these numbers are kind of goofy on this problem, but nevertheless, our answer will be correct and it'll give you an idea. So a stock screener would like to identify a hurdle rate such that only 1 in 20 equities is above that value. What should that hurdle rate be set at? So 1 in 20, right? We're talking about, and maybe this is the complexity that they add into it here, is a 95%, right? 1 divided by 20 would be 5%, but we want to be everything below that, or up to that 95%, if that makes sense. Okay, so again, using our good old formula that we have here, z is equal to the x minus our mu, and I've just rewritten the formula, and if I take this and I do it kind of like I did on that last problem, but x then is equal to our mu plus our z times our standard deviation. Okay, and so what I have to do is find that z value, right, to plug in here. I've given the standard deviation here, and I'm given the mean. So once again, how do I find that z value? I look at the chart, and I can come down here, and what I do is I look through here, and I gotta just kind of keep going until I get to 0.45. Okay, again, I add the 0.5 to that, so 0.5 plus 0.45 would give me 95%, right? Okay, and it's right in between here. Okay, so it's 0.4495 and 0.4505, exactly in between there. So I got 1.645 is how I come up with that. That's kind of we'll use that 95% number a lot, even as throughout the rest of the semester. So you kind of get used to some of these, and this is the value of 1.645. You kind of get used to. So now I've got all my stuff, right? I've got, well, x is equal to my mu, or my mean, plus z, 1.645, times my standard deviation. Okay, and I think I've done that math right in here then. Excuse me. Okay, so I've done that math. It's equal to my mu, or my mean, plus, and hit my parentheses, z times my standard deviation, in parentheses, hit my enter, and I get 0.416, or 41.6%. And like I did up here too, I can also do the normal inverse. Most recently, there we go, probability, mean, standard deviation, and there we have it.